Okay guys, so let's do the following spherical problem, alright? So we are inside of this sphere. Doesn't really look like a sphere right now, but trust me, you'll see it is. This right here is a cone, and we are below it. And we want to figure out, like, okay, what is the integral? What is the total mass of this region given the following density? Where the density is the distance from the origin. Alright, so let's get down to it. So the first thing I'm going to do is just probably the most straightforward way. I'll do the more clever, thoughtful way later. But let's just do it at the way you probably just want to do it on the exam, alright? By just converting, plugging in stuff, and then maybe drawing a picture just to make sure you're right. Alright, so let's go. So let's just convert this stuff into spherical coordinates. Now why do I use spherical? Because hey, look, a sphere and a cone. That's what spherical is built for, is spheres and cones, alright? So, okay. So let's start converting, alright? Let's see. So let's convert this part right here. Now, okay. How do I convert this? Let's see, let me just write out over here just some of the conversions. So like z is equal to rho cosine of phi, x is equal to rho cosine theta sine phi, and then y is equal to rho sine theta sine phi. Sorry that's so small over there, that's a sine phi right there, okay? Alright, so looking at this here, this part right here, that's just a rho squared, okay? That's going to be rho squared. And this part right here, let's see, oh, there's a z. This is going to be 2 rho cosine phi. Alright? Okay, so where do we go from here? Well, we have basically rho's throughout here. So let's get rid of that extra rho, okay? That's just completely unnecessary, having that rho in there. So after we divide out rho, we get rho equals plus 2 cosine phi. And this thereafter turns into, excuse me, this should just be, I divided by rho, so I got rid of that rho, and I should get rid of one rho here. So that's no longer squared. And this turns into rho equals negative 2 cosine of phi. Okay, so there we have our equation for that sphere. It is rho equals negative cosine phi. Great, great. Let's convert this guy now, just to get that out of the way. So this is going to be a little more involved. This looks like the following. Let's plug in z. So this turns into rho cosine of phi is equal to negative square root of then this squared plus that squared, okay? So rho squared cosine squared theta sine squared phi plus rho squared sine squared phi theta sine squared phi. Okay, now we see, okay, same rho for both of these guys, same phi. So the only thing that's different is these two parts. So that turns into negative square root of rho squared sine squared phi. And then I have this plus that. And we all know what that is. That's just going to be 1. So this turns into 1. This, we're going to take the square root of that, so this is going to turn into just rho sine phi. So I end up with negative rho sine phi is equal to this guy, rho cosine phi. Okay, now look at this and I think, alright, how do I simplify this? Oh, they both have a rho. Let's cancel that out. Negative sine phi equals cosine of phi. Alright, where do I go from here? Well, let's see, if I divide cosine by sine, that'll get me tangent, so let's convert that. So negative tangent phi equals 1. Let's see, let's move that negative over there. So let's make that into tangent phi equals -1. And now I have to figure out what that phi is, okay? And because I have pathological difficulties with figuring out that phi, let's just draw the picture, okay? Or let's also remind ourselves, what is tangent? Tangent is opposite over adjacent. Okay, so let's draw this out. So let's see here. A phi goes from 0 degrees, which is up there, all the way down to pi degrees, which is down here. It never goes over there, alright? So let's see here. I've got opposite over adjacent. What does that look like here? Well, let's see. The angle's right here, theta. And let's see, opposite, adjacent, right? This feels a little bit awkward, but we know since this is 0 degrees here, that the triangle is making that angle, excuse me, that shouldn't be theta, that should be phi. Here we have adjacent, and there we have opposite all the way up there. Okay, now what do we have here? We have that -1 equals opposite over adjacent. Another way of writing that is negative adjacent equals opposite. So that means that if one of these is positive, the other one of these is negative. Let's see here. In both these situations here, they're both positive, right? This is a positive length up, this is a positive length out in the x direction. So that means that it's not up here actually, but all the way down here. Okay, so let's rewrite that. Let's try to write this guy beneath pi over 2. Alright, so here is my angle, phi. Right, instead of up here, it's now all the way down there. This is going to be adjacent right here. This is going to be opposite. Okay, now we see opposite is negative. You know, it's at a negative y value down here, while adjacent is positive. So that means, okay, yeah, one of them is negative, namely opposite, and one of these is positive adjacent. Now what else do we see here? That these guys have the same magnitude, right? The same absolute value. It's just the only difference is that negative. So that means this length is the same as that length. Let's see, when does that happen? When this is going to be 3 pi over 4, right? As in, this right here is already pi over 2. And then this part down here is going to be pi over 4. You add those two together, you get 3 pi over 4. Okay. Now another thing here is, one thing that was nice about this is you don't make the mistake of getting your answer as, because if you just took the arctangent of -1, one value you might have gotten for that, excuse me, I'm reversing this, as -1, you get pi over 4, negative pi over 4. Now one thing is, this should scream at you that this is wrong, because phi can never be negative, okay? You're never going to go in that direction, okay? It's always positive. It's always somewhere between 0 and pi. Okay, and this diagram helps us to figure that out. We knew it had to be negative, had to be past pi over 2, because of the fact that this was negative. And we knew that, basically from the fact that, oh, the magnitude of these guys are equal, that gives us that extra pi over 4, and then we have it. Okay, so that's great. So we now know that phi is equal to 3 pi over 4. So let's just write that up right here, okay? Phi is equal to 3 pi over 4. And this, what was the other guy here? Rho is equal to -2 cosine of phi. Okay, now, where do we go from there? Now that I've nicely converted those two equations we were given, what should the rest of this be? Well, one thing is that we're going to need like 6 different bounds for like rho and theta and phi. So the only real way to get that is to make a picture, okay? Because we're going to have to figure this out just visually. What are the remaining bounds? Okay? So, let's figure this out, okay? What should this be right here? What is actually this look like? One way to figure this out is to do the following, okay? You look at this and you think, okay, I got a z squared and a plus 2z. How will we complete this square, okay? So let's rewrite this with an extra 1 on the end there, alright? So that this becomes z plus 1 squared plus y squared plus x squared minus 1 equals 0, okay? And this then gives us x squared plus y squared plus z plus 1 squared equals 1. Okay, now I know what's going on here. I know what this guy looks like. This guy is going to have what center? Let's see, 0, 0, negative 1. That's going to be the center. What's its radius? 1. So this is the center, the radius is 1. So let's see, if this is x, y, z, then 0 forward, 0 to the right, and negative 1 down, or negative 1 up. So here's our center, radius 1. Okay, we get a circle like this, or a sphere like this. That's what he's shading if you can't tell. Alright, so, where do we go from here? Okay, well I understand now what this guy is all about. Let's understand what that guy is all about. Alright, what does this cone look like? Well, I can either do this one of two ways. I could either look at this or I could look at that. Either of these is fine. So I'll look at this quickly to figure out what the cone looks like. So what does this mean right here? This means your distance out like this, okay, in the xy plane. Okay, so let's see. If I move 1 out on the xy plane, then that 1 will be multiplied by negative, and I'll get negative 1 for z. So I move 1 out, I go down 1, right? So I'm right there. Same thing if I moved forward, 1, it'd be down 1, or diagonally 1, it'd be going down 1. So it looks like I am like this, okay? The cone is below me like that. And alternatively, if I look at this right here, I thought phi equals 3 pi over 4. That means that, let's see, if this is 0, and this is my phi, then let's see. I go all the way down, pi over 4, pi over 2, 3 pi over 4. Oh look, this is cutting out a cone. This is cutting out a skirt sort of around me here, okay? So, okay, that means that this guy is a cone like this. Okay? So that means that since I'm below this cone, but I'm inside this sphere, okay? And if you wanted to draw that out a little differently, it'd basically look like this. Okay, because I'm bounded by that cone, and then there's that sphere that I'm inside of, which is right there, okay? This is an upside down ice cream cone, okay? The cone makes the ice cream cone, and the sphere makes the ice cream. Okay, so that's great, we're clear on that. Now, let's figure out the actual integral, okay? So let's see, let's set this guy up. Alright, so, okay, so here is my 3 integrals. Let's throw in, I'm going to leave this blank for a second, this is where my integrand's going to go. Since I'm in spherical, I'm always going to throw in that rho squared sine phi, okay? And then I'm going to have some my d's here, okay? I don't know which is the right order for my d's yet, but I'm just going to put them there so I know that I have to do that. Okay, so what is my integrand? What am I putting in there? What am I integrating? I'm integrating density. What is my density? Distance from the origin. So, what is distance from the origin? Oh, that's really easy in spherical. That's just rho. Okay, so what I'm integrating here is rho cubed times sine phi. Alright, now let's figure out what order these guys should be. How do we figure that out? Well, let's first figure out what the bounds for phi and theta and rho are. So let's look at these guys. All right, let's set this up. Rho, greater and lower bounds. Phi, greater and lower bounds. Theta. Okay, so let's start off with rho here. Do we have any information on rho? Yes. Yes, we have some information on rho. That's -2 cosine phi. Okay. Let's see. So let me think about this for a second also. What does it look like here when I do rho? Well, the idea in a sense is, okay, I choose like some, theta and phi, okay? Some sort of theta, way I turn like that, and then like phi down. And then I basically decide, okay, I've chosen a ray. Alright, I've chosen a ray that is going in that direction. And I want to know, when does this ray start? What part am I looking at for that start? And where does it end? Okay? If it starts at my elbow, then that means that my rho is 0. Okay? And there's going to be somewhere further down my arm where that ray will be cut off. Okay, so let's look at the diagram here. So you can imagine that, okay, I go in some direction, all right? There's some ray. And let's see, he starts here at the origin, and then he gets cut off by the sphere here. Okay, so if you're starting at the origin, that means that you'll be 0, and then you go all the way down to that sphere there, and you get cut off by it, so that means that's your endpoint. What's the sphere? Let's see, here's the sphere in spherical. Oh, rho is equal to -2 cosine phi. Now I look at this, and I feel a burst of anxiety, because why is this negative here? That is really weird. I'm going to get to why that is negative in a second, though, alright? Because it feels like, isn't rho always positive? How can we have a negative here? So we'll talk about that momentarily. Let's first talk about phi, though. Alright, what are the bounds on phi? Alright, let's see, what does it mean for phi? The idea is it's sort of like, okay, we see what sort of cones am I on? So basically the idea is, here we have 0 up there, pi down here, and sort of what sort of cones am I looking at? I'm looking at this cone, that cone, that cone. What are the angles that I'm concerned with? So, so do I have any information? Well, I have this right here. 3 pi over 4. That's my sphere. Okay. And let's see. I am below that sphere, right? I'm below that cone, right? So, that means that, let's see, I'm starting at this cone, and then I go all the way down to here. What is, and basically to the South Pole, or straight down. What is the South Pole? That is pi angle with the North Pole. So that means that I start here, 3 pi over 4, and I figured out the alternate bound of pi. And what about theta? Well, let's see, there's really nothing on theta. This guy goes all the way around, okay? If I maybe cut it in half with like by the YZ plane, if I cut it like that, then I'd have bounds, or I cut it with a plane like this, I would have bounds, but I don't have any such planes. I go all the way around, so this is going to be 0 to pi. Okay, now I have all of my bounds, and I'm ready to figure out what order they should be. Now, how do you figure out order? You figure out order by what depends on what, okay? So let's see, rho. Is it dependent on anything? Yes, it is dependent on phi. Okay, so that means rho has to come before phi. Let's see, is anything dependent on rho? Is theta dependent on rho? No. Is phi dependent on rho? No. Is theta dependent on rho? No. So that means rho can very happily go first. 0 to -2 cosine phi. Now I promised I'd explain why that can be negative. The reason why is because look at my phi. Look at the values of phi. that I'm going on. I'm going from 3 pi over 4 to pi. Now what is the graph of this guy in terms of phi? So here's phi, here's rho, okay, and let's graph this guy out. So let's see, that's going to be -2 cosine of phi. So I start down here at -2, and I then decrease, and then I stop there at pi. And here's pi over 2. So, oh, okay, so this guy, this -2 cosine phi, he is positive from pi over 2 to pi, and look, our bounds, the part we're interested in, is inside of that positive section. Killer. Alright, so that means that this is positive for the relevant values that we are concerned with. So this is perfectly valid value for rho because we have shown it is positive. It's all of these guys. Okay, so now what do we do next? Well, let's see, it doesn't actually matter. Neither of these guys depend on the other one, so I could do it either way. I'll do phi because I don't want to be unnecessarily spiteful to you guys. And then let's do theta because theta is the last guy here. 0 to 2 pi. Okay, and now we've set up the integral, which is the hard part. Alright, so there you go.